All right, students, we're going to be going over Module 2, Homework 3 and 4 together. Now, Homework 3 and 4, like I said right here, if you can look up here for a second, it says that it is 3 and 4 together. So when you guys are doing your homework, recognize that 32 questions are addressing both homework assignments on this course syllabus. And the course syllabus obviously shows that like that. Don't pay any mind to the dates, for that might be different for your particular class. Just making sure that you understand where we are. All right. So now when it comes down to functions, functions are functions when there's a one-to-one relation. And that means for every single input, there's only one unique output. And if I go ahead and look at this particular equation right here, and I don't really need to draw it, but it's got a line that's going up and down like this. And if you take a vertical line, that's always kind of nice to see. All right, so if I had this graph, and it looks something like this, right? I'm trying to mimic a little bit about what it looks like. But if I take a straight edge and just run it straight across, there's not a single point where I'd be contacting that graph more than one time. That's the way you got to look at it. Now, this one it says select all the following graphs which represent y as a function of x. This represents y as a function of x. Whereas this one right here does not, because if you look at it in this one, all right, if you were to take your pencil or some kind of an animate object that's a straight edge, and you go ahead and hit the graph at this point, you'd be contacting the graph at this point, and this point. So that would be three contacts and that means for that particular point of interest of, let's say, x equals 2, there would be three output values for that unique input value of 1, input value of 2. So that would fail to be a function. So that's when we say that you have a slew of like a kind of like a selection of points, and you can't have the x repeated because that means one unique x input has multiple outputs. So that's where we get into then the ones that would pass would be this one would pass, this one would pass, and this one would pass. All right, these two would fail because this would hit at 2 points. These indicated values like right here and right there, so anyway, it'd fail at multiple points. So those are the answers that we're looking for, okay? And you can see them all listed right there. All right, now for question number 2, so this was question number 1. For question number 2, then we look at it and we're remembering keeping this concept in our head. It says the set of all possible outputs for a function is its what? Now, the outputs is, okay, so I'm going to have to go ahead and say the inputs. I'm going to give you these words right now. Input, all right, input. Oh, if we can silence ourselves. Right. I need a silence. You can put your speaker on silent. Hi. All right, I went ahead and muted that person. All right. Now, input is going to equal, the input is equal to what we call the domain. All right, domain. And when we're looking at domain, okay, that's all Can you hear me now? Okay, thank you. I love technology. All right. So again, input equals domain X, output equals range Y. So when we're answering this question, the output, as it's indicated, equals to range. Okay, so that's going to be our answer for that. Now the notation that we deal with, question number 3. All right, question number 3. It says the notation when we say that y equals some function. This, I won't actually give it away. Um, this is called a function, and it's just notation. It doesn't mean that k is multiplying x. That does not mean what that does not say that. It says that k is a function of the input x. That's what this is basically saying. And then when k is a function of some input x, that's creating the output right here. This is creating the output. And what is the output? The output is the range, and the output is the y value. So that's why we say that this is called function, because um, it's some value of that's produced within the equation, and that's why it's the output, and the output is the range. So we have then this called a function. Okay, so that's why we look at this as a function. Don't get confused with thinking that this is k implying something. That's a common mistake students make. All right, now number 4. Now it says select all of the following tables in which y, as a function of x. Now, when they word things like this, now I'm going to go ahead and share with you the answer. Let me show you. And then when we see this, okay, we have then the y's are able to be repeated, all right, and then the x's are not. So when we look at this as a y as a function of x, we're looking for where the x's are not repeated. And if you look at the very first one here, you can see that x is repeated. And that's just like this kind of beat, it's like beat up, or it's got some kind of an output that looks like this, where it's going to have an output on top of itself, okay, or one after the other on the same input. So we throw them out, okay. So this one's no good. All right, that's the one that we want to throw out. Now it says select all the following tables in which y as a function of x. So we're constantly looking for, is there any that have x is repeated? And we can see that this one does have x repeated. Therefore, we have to throw that one out. So therefore, we go ahead and select the two values of, and this one has a repeated x value as well. So we throw that one out. So this is really easy. Just select where you're going to have any x repeated, and that would be this one doesn't have it repeated, and this one doesn't have it repeated. So that's the two answers that we have here. This is pretty straightforward. I can't emphasize how easy it is. And then, of course, I've already instructed this. This is select all the following graph that represents y the function of x. This would be, this wouldn't be, this wouldn't be, this would be, this would be, and this one would be. That one's just like the one we did over here. Okay, so those are the answers that we're looking for. Okay. Yeah, those are 4 of them that we said. Okay. Now, for question number 7. I already did this one. All right, so now question number 7. Now it says find the domain and the range of the relationship. Now the domain is going to be all values of x, as I just said right here, and then the range is all values of y. So when we have a coordinate point made up of an x and y, all right, we are looking for then the input values are going to be the -6, and you can see that -6 is repeated multiple times. So this is just going to be the value of our answer. The domain is -6. All right. Now the output values are going to be, and we don't put them in parentheses like that. We put them in braces. But then it's going to be 9, 9, 8, 7, and to put it like that. Now, the order of which you put them in should not matter, but it is nice to put them in order from least to greatest. Okay? Stay after class if you didn't get to sign in, okay? I'll sign you in after class. Now, we have this, okay? Now, the thing is, remember what I said, you can't have inputs repeated, and we only have one input with multiple outputs. So therefore, this is no function, okay? So this is no, it's not a function. But again, if you put in 9876, it would accept it as an answer, by the way. I just want you to know that. So again, we're looking for domain is -6, -5, -4, -3. That would work. All right, that's the answer we put for there. And then for the range, we put 6, 5, 4, 3. And then that is in fact a function. All right, for every input has a very unique output. All right. So that's the answer we're looking for. Yeah. Now, number 9. Now these get people confused, and I'm glad to be able to have the opportunity to go over these with you. They're not hard, except you need them a little bit. Okay, so when we look at this, we're looking at it from the perspective of domain is looking at it from left to right. So you're looking at from the left and you're going to the right and you're looking at it. All right. For the range, you're looking at it from the bottom to the top. And that's how you got to look at it always. Always domain. I mean, give yourself some notes here. Domain is that one and range is this one. Okay. Let's make sure we understand from left to right, bottom to top. Now, for domain, we're looking at it from -1, because it starts at -1. It has a hard circle. What does a hard circle mean is that it's inclusive. It means it includes that value that you're looking at. Okay, so it goes from, and the way you do it, okay, you state your domain, it goes from -1. Now, I'm curious as to how, I think they want it in interval notation. Yes. See it in the instructions, this is interval notation. So we want to put a bracket at the value of -1, and then we go to 2. And now it's dropping down like this, right? It goes like that. And then it doesn't have a closed circle, it has an open circle. So I'm going to erase that, and I'm going to put an open circle at that value. All right. Now, because it's open, it goes all the way up to 2, but does not include it. That's what interval notation states. So look at the answer. Okay. The same answer as I have here. So -1 to 2. Now the range, I'm looking at it from the bottom to the top. Remember, don't start over here. Start here, because I'm looking from bottom to top. Now, the thing is that this thing goes up, above this point of interest, doesn't it? It goes over this point. We're not concerned about this point. We're concerned about the highest point. So it goes from the value of 0. Now, what we're looking for is the range value. We're looking for where it is on the y-axis. So on the y-axis, what is that value here from that point that's open? And that's at the value of 0. That's 0 all the way up to, you get to the top of this, and what does that value equal? 4. So it goes from 0, which is open, and it's going to be open at this value as well. I think it's open. It might be closed. I think it's closed on these. When it's right like this, I think it's closed. Okay, so yeah, I'm going to say closed. So it goes to 4 and it's closed. I'm pretty positive that's closed. All right, yes. See what I mean by saying open and closed? See right here, 4 has a bracket. You've got to put the right bracket sign. If it's hitting like a pinnacle point, it's called the vertex of a curve. So when we do that, at the highest point you go, that's going to be your closed bracket, 4. Right? See, so this takes a little bit of time. It takes a little practice. This one, you got to be patient with yourself. Don't judge yourself on it. Not completely easy to do all of this. I mean, but
It's not impossible either. Now, the set of all possible inputs, we talked about output before in the last question, or that one question delta things. But then input is domain values, and that's x. So when we're looking at this question, the answer is the domain for the input values. It's good to get this vocabulary in there because I'm looking at how do you answer question number 9 and question number 11 if you don't know what domain domains are. Okay. And I love this little picture that I gave you. I hope that you really pay attention to this because that is the key to being able to do these. So when we're doing domain, again, number 11, domain is left to right. So we're looking at from, and I'm going to go ahead and blow this up and make it bigger. I'm going to go ahead and explain it that way too. From left to right, it starts at -3. So I'm going to go ahead and start at -3. And notice how I'm looking at the values of what's on the x right now because that's domain, isn't it? So domain is looking at the x values. So it starts at -8 all the way until you get to 2. But now it's 2, it's open. So we're going to go ahead and put a parenthesis there. So that's the answer we're looking for domain. Now for range, it starts from bottom to top. Look at this. We're starting at, now we're looking at for range, the y values. Okay, so that's this axis now. So where the y values, it starts at -5. And it goes all the way up until you get to +4. So that's going to be inclusive again. Just like this last one that we did over here, right? This one we did over here. This one was at 4 at that point. Well, the same thing goes for this one. All right? So there's our answers for that. Now notice I didn't care much for the value of 2 when I was looking at the range. I cared about how where did it start and where did it end as far as the top goes. Okay? So those are answers for that question. So let's look at the key. Here is exactly what I gave you, and then also exactly what I gave you. All right, and is the function a function? Yes, it is a function, of course, because it passes the vertical line test. All right, so that's question number 12. Now let's look at number, well, that's question number 11. Now let's look at question number 12. All right. Now for 12, it says you have this function called k of x, and it equals x. Now, anytime you have a function like that, then we can also look at it as y equals x. You're going to get what's called the identity function with that particular function. So that means it goes like this, by the way. Now let's talk about why we look at this. It's because for every input, it's equal to the same thing as its output. Right? It's, if I give you 1 for the input, then it's going to equal the k of x, which is the same thing as saying y. Remember that thing we talked about earlier. So that means we have a coordinate point of 1, 1, 2, 2, -5, -5. For every input you put in for x, it's going to equal the output for y. So if you go -5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5. Look at, we're landing on that graph that we just did there. So that is called the identity function. You're going to learn about this in college algebra as well. Okay. So the domain for this, now we got this. This goes on forever, by the way, and this goes on forever. The domain for this is always going to be from -infinity to +infinity. That's the domain. Well, likewise, that's going from left to right. This is going forever and ever 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 down forever. So that means it's coming from -infinity, and it's going to +infinity because it's going to go on up forever and ever and ever. But while it's going up, it's also going to the right forever and ever and ever and ever and ever and ever. And that's why we put +infinity. Now, the likewise, it's coming from -infinity because it's going always down, 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 down. So it must mean it's coming from -infinity, coming all the way from the bottom all the way to the top. Is going up forever, never, 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 never. So that's going to be positive 3. So with identity functions, domain and range are going to be identical. That's what you get out of it. And now I instructed it to you about why. Now you understand, and you get the same exact answers of negative infinity, positive infinity. All right, write the answer in interval notation. We did that. We would do that, and I did that right here as well. Is a relationship a function? Yes, it passes the vertical line test. See, so it's nice about this is when you do the drawing, you start at 0, 0, and you can go up to 1, 1, and you can see that graph going for you, and it's pretty fast to then determine the same exact thing as it did for you here. Okay, nice why I have grade paper here. All right. Now, what is the domain of the function in the graph? Now, it goes from 2 to 5. So it's inclusive, so it's going to be 2 to 5, and that's the only one. Now, thing is that recognize the domain is related to P, not to K. K is the output, P is the input, and when we talk about domain, we're talking about input, and that was why it's P and not K. So K is thrown out. K would be the Y value, and if that was the case, then we would go from 11 to 14, and that would be the range. So the answer is going to be the first one. All right, so we were asking, now also make sure that sometimes they throw you off and they put a just the less than symbol and not the less than equal to. You have to, the only way to be just the less than is if this is open here, and that's not the case now. All right, now determine the domain range. It's still, this is just practice, 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 practice. It's getting different types of problems, but a lot of them are very, very mimicry to each other. They're very similar to each other. So when we're talking about domain, again, you're looking at where does it start from the left. It starts at -2, and it goes to negative, not negative, but positive 3. Okay, positive 3. That's where it is. All right, for the domain. So for the interval notation, we would say inclusive to -2 and not and exclusive to positive 3. Now for the range value, we're going to be starting at -5, but exclusive. So we're not going to include that value, and we're going all the way up to 4. It seems like they like 4 a lot. And remember, you're going to be including that. All right, so those are the answers we're looking for that. All right, and that's what I have here. All right, we're doing the same idea here. Domain written in interval notation, it goes from -5 to 2, and that would be exclusive to -5. So I'm going to go ahead and put -5 to 2. And then the domain written as subfill notation. That's unique. So let's go ahead and talk about that. So the subfill notation, it's always the same thing. It has a little bracket, X, and a line. And all it is it goes from -5 to 4. So you would go ahead and put -5 and then open, less than. The value of our variable would be X because we're dealing with the input value of X. So these should match. And then we're going to be this one is including the value of 2. Okay? And that's how you write your set building notation. So set building notation is writing what you write here. So I didn't write this down, by the way. This is not for this problem. Just don't use this is for the other problem. And then we're going to go ahead and recognize that this is how you write the set building notation. Okay. See, this should tell you that this is going to be a less than symbol. This should tell you it's going to be less than or equal to symbol. All right. So now let's look at the answer. And I have exactly that. All right. Now the range, again, we're only looking at the value of the Y value now. This is where, like I said, students get really rocked. They just aren't, they remain confused, it seems. But you're looking at from bottom to top. And it goes from -1 here to positive 1 here. So it goes from here to here. So then it's simple then. It's going to be from negative 1 inclusive to positive 1 exclusive. So bottom to top. That's what this was so important for me to explain this to you earlier. Okay? So you've got to realize that. If you get that wrapped in your head, solid, with no question marks, then you're going to be able to address range and domain pretty quickly. So let's take a look at the answer. I gave that to you here. All right. And now, when you're doing your septal notation, it's going to have the y now because we're dealing with range. And so it's going to be from it's inclusive, negative 1, y this time. Remember that y. And then it's going to be exclusive to that 1. And then we're going to put little, well, we don't have to put that in because it's already been into this. But you'll notice it's right there. But here's all you got to do is plug it in what we have here. Okay? So don't mix up the variables. You're going to get this wrong if you do. All right? So. And then we repeat the process. Domain, I'm going to go a little quicker because it seems very repetitive. All right, so domain, it goes from negative 1 inclusive to 3 exclusive. So that's going to be an interval notation. Inclusive is the bracket, so negative 1 to exclusive parentheses for the 3. The range, it goes from negative 5 to 4. Seems like we've had that question before. Very similar anyway. So recall that it'd be negative 5 exclusive, so that's why the parenthesis doesn't equal to it because there's an open circle and not a closed circle. Now it says find the domain and range of the following function graph below. Now when you're dealing with this and you don't see any hard circles, meaning you don't have exclusive, inclusive points like this and this, right? We're looking at then determining what does it look like when we're dealing with this. Now, with quadratics, you've got to realize from domain and range perspective, it's coming from the left and going to the right for eternity because it's always going down, 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 down. So that means it's always going to the left, which means it's going to negative infinity, this direction. And then it's always going to the right as well, so it's always going to positive infinity that way. So that means that all quadratics, if there are truly functions, meaning they're not written like this, then they're always going to have the same exact domain, and that is from negative infinity to positive infinity. That is domains for quadratics. Now, from the perspective of range, then it's going to be some limitation on range because it's not always going to go up, 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 up forever. So it's right now it's coming from negative infinity because remember it's going down forever. So it's coming from negative infinity if we look at from bottom to top. So it's going up, all right, up to some point of interest, and that is at the point of negative 3. It stops going up, and it goes up, 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 up. Now it stops, and then it goes back down, 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 down. All right. So it's always doing that. So it's coming from negative infinity, stopping there. So then we're going to say inclusive 3, and that is inclusive negative 3. All right. So domains always negative infinity to positive infinity for quadratics, meaning U-shaped like looking figures. And then the range is always going to go if it's going down, down, down like this, it's always going to be negative infinity to where it stops going up. Now, if it's written like this, if it's like this, all right, then it starts at this point of interest. Let's say it's negative 2. I don't care. But negative 2, so it would be inclusive to negative 2, but then it goes on for infinity, going up, up, up forever. And then, but it's still a domain. It's going to be from negative infinity to positive infinity, because that's how domains of U-shaped like looking figures like this quadratic always functions on the domain of negative infinity to positive infinity. So the range is affected by then if you're having standard upward bound travel like this from negative infinity, or negative 2 for this case, all the way up to infinity. All right? So that's how those work. Now, I've given you two scenarios, and one being the one we're given, and then another hypothetical. All right, now let's look at this next one, question number 18. This one right here, all right, is it's actually a square root function, but its idea is it's going from somewhere. Let's see, it's going from 1, 2, so it's right here, and it's going on for like this forever. So when it's going on forever like this, all right, it means it's going up and to the left forever. All right. So when we're going to the left forever, it's going into the negative realm, obviously. So the domain is going to be from negative infinity because it's coming from the left to negative from negative realm to negative infinity, and always put parentheses around an infinity sign. Never put a bracket. But then it stops somewhere. Where is that stopping? It stops at 1. So it's going to be inclusive as well for the domain. Now the range, all right, is from bottom to top. It starts at 2. All right, it starts at 2, and it goes on forever up. So it's going to be positive infinity for that, for the value of that. Okay. So I know I was off the frame for a little bit there. So there's what I was drawing. Okay. So here we have the answer for that one. I gave it to you, and this one as well. Looks like my answers are matching. That's always a good thing. All right, now the domain and range of this. All right, people get confused on circles. All right, but look at the circle and be careful when you're drawing or looking at it, because the circle, just like you do anything else, it goes. Let's one. All right, it starts at here, goes from here. 1, 2, 3, 1, 2, 3. Let's say so myself. This is a pretty darn good looking circle. I do pretty well in it. So anyway, if we're looking at it, it goes from here for the domain, goes from here to here. So where is that? That's from negative 3 to positive 3. And from negative 3 to positive 3. So it's the same answer. For this is negative 3. All right, this is positive 3. And now I want you to take note, all right, here, that they're both inclusive, because remember I was telling you about the other curve. It's this is the highest point it goes, then this would be why we would say it's inclusive when you're writing your answer. And likewise, you'd have the same exact answers for both of the circle. Okay. So that's the circle. Now these are what we call abstract functions. They're not like the square root function. They're not a circle. They're just abstract. So the domain, I mean, we don't operate any differently on how we read them. We're reading it from left to right, so it's going to be non-inclusive to negative 4 to 4. That's the answer we're looking for. Both of them having parentheses. All right. Now for the range, it's going to go from negative 4 to positive 4 here as well, because it goes from here to here, and that's the lowest to the highest point. So then when we're looking at that, okay, we're writing the answer as inclusive as well. Inclusive for both of those, exclusive for the other two, because the other two have open circles up them, okay? So be careful on that. This shouldn't be any different from what I've been doing earlier, so this should be pretty familiar. Now the domain for this one, it starts at negative 3 here, goes on to infinity. So that's why we'll see it as negative 3 to positive infinity. After all the explanations I've been doing with these several different graphs, this shouldn't be too difficult to realize. Now the range, since it's like this, it's going on forever and ever. Then it's going to go from negative infinity to positive infinity. Now, is this relationship a function? It absolutely is not a function because it fails the vertical line test. And there we have number 21. 22, you'll notice how I'm writing a lot less because this is just reading it. So the domain, it's going, you see that arrow, it means it's going on forever to the left, forever. So that means it's going to negative infinity. So for that, then that means that I'm going to be going negative infinity all the way until I stop at the value of 8, but don't include it because it's an open circle. So there we have our answer. All right, now for the range, remember it's going, as it's going to the left, it's also going down. All right, as it's going to the left, it's always going down. So that means it's going for the range, right? Always good to specify, but it's going from negative infinity all the way up until it gets to the value of -3 for that. But that's going to be again open parenthesis because it's an open circle. All right, it goes all the way up to -3, but does not include it. So I think by all the many examples I've given you, now you fully understand that what I'm looking at is the x values for this and the y values for that. For 23, all right, now we're looking at 23. All right, we have now a value system of input creates output. Remember, this is a function. So I'm looking for what is the output when I put in -2 into this equation. Well, I'm looking at the graph and I'm looking for -2 and I'm finding out where does this line that's on this graph crossing over, or what would it equal for the output value if I put in -2. So I put in -2 and I'm going to go ahead and see that -2 is going to have, I'm not at the point, but right here, we're looking at -2 and the output value is about 3 point something. I mean, it's, I don't like this question exactly because it doesn't have a hard point at that value. I'm wondering if what the answer they're choosing for this one. Yeah, I was about to say, it looks like it's a 3.3 situation. So this one was a bad question. However, not impossible to realize, but until you know what the function is and having output, because this is like right here, all right, and that point, is it easy to say that that's 1/3? Not quite. That's very, presumptuous of us to say that it's 1/3. So that is what 3 continuous is. So that's dangerous. I don't like this question for that reason. The only way I would do this question is if I had identified the equation itself, and that is by looking at what we did earlier. Okay, this is the only way to do this one, is to recognize that y equals mx plus b, right? We would have to go ahead and say, well, the b value is the y-intercept, so that's 2. What is our slope? And our slope is going, what is it doing? It's going down 2 over 3, down 2 over 3. And now we go ahead and put in the value of -2 here, all right, for the value of input. So that's what we're looking at. And now we're going to go ahead and say this is -4 over 3. This is 2, so this would be 6 over 3. And then this would be the value of 6 minus 4. All right, and 6 minus 4 is 6 minus 4 is 2. I don't like that. And then we get the 0.3 continuous, or 0.6 continuous. So that doesn't make sense either. So then wait a second. This was negative. That's negative. So that makes sense. That's where it makes sense. Okay. So that was -2/3, which is a downward slope. So now we have down 2 over 3. Yeah, that makes sense. So now we have 10 over, I should put it here, 10 over 3. And then that's when we get 3 1/3. So like I said, I did not like this question. The whole reason why I don't like this question is because you can't just look at the graph with identify 3.3 continuous. See, so if I look for 3 input, I'm looking for 3 now. I should be able to produce the output real quick. 1, 2, 3. Look at that. The answer is 0. See how like I could find the value of the output real quick? That is a lot easier. All right. And that's the way it should be for this. All right. So now when we're looking at this, okay, it says the output is 8 over 3. Now 8 over 3 is the same thing as me saying, well, it's going to be 2 and 2/3. That's what we're looking for the value, all right, of output. So let's take a look at our value system. The output is 2 and 2/3. So 2/3 right here. I look over here and I see that it's equal to -1. That's going to be our input value is -1, because that's where the value of 2 and 2/3 is for the output. So my answer is going to be -1 for that one. And I have the answer there. All right. Now the output is 4 over 3 is the same thing as me putting 1 and 1/3. So I'm looking for 1 and 1/3 for the output. So I look for 1 and 1/3 is right about here, and that's going to give me +1. See, so I can see now this where this is going. All right. So this is going to be the value of 1. All right. So I put 1 in there. All right. For the output, or for the input would be 1 when I have the output as 1 and 1/3. Now that's when you're looking at graphs. Okay. Now they're going to give you equations, and you're going to go ahead and put them in and produce output values. So input is -2. So we have the function 2x squared. So I like to do it, write it out like this. So just the replacement is where I have parentheses. All right. So where I see parentheses is where I'm replacing these values. So it's going to be 2, and then -2 squared, -8 times -2, and then +3. So when I do this, this is going to be 4 times 2, and then -8 times -2 is +16. And then I'm going to go ahead and get 8 plus 16 plus 3. And then this is going to give me 8 plus 3 is 11. 11 plus 16 is going to be 27. So our answer is 27. All right, and let's take a look at it. There's our output. All right. Now, it'd be really, really nice if you had a graphing calculator. Now, I'm going to show you and by the way, you should, if you have the financial ability, you should probably invest in this because you need the college algebra anyway. But I'm going to show you how to use the graphing calculator. Watch this. Now, you're going to hate me for showing you this, but let me clear all these out. I'm sorry. Here. All right. I want to punch this in. X, or 2x squared, and then -8x, and then +3. Enter. Second graph, and I have all my values. Here are my answers. 27, 13, 3, and then I have -3, -5. I'm done. There's my answers. I don't have to put them all into the or write them all out physically. I know you're gonna hate me for that. You know, that is a lot easier to do it on a graphing calculator. You're probably thinking, I need to get a graphing calculator right now. Yes, you do. If graphic calculator, I know that that's a really good way of doing it. Yeah, it's really fast. I mean, I tell you, a lot of people would love the graphic calculators. If you have one, I strongly suggest that you get one. Okay. Um, all right. Yeah. Yeah, I know it's a lot of fun. I mean, it does take a lot of the fun out of this, but the concept doesn't change. All right. The way you do the process is just like if I do the second one, I do x 6x squared plus 4x. And notice how I'm going to put those parentheses in there because that's a good way of doing it. All right. Now, if you put in zero, zero times anything is zero. So zero, zero, that's just, the answer is this one. All right. So I get -5 for that answer. That's pretty nice. All right. Now, when I put in 2, 2 squared is 4, 4 times 6 is 24. All right. And then I do 2 times 4 is 8 minus 5. And then the 8 minus 5 is 3. 3 plus 24 is 27. All right, so then we have that one. All right. And again, you would put in -2. All right. So -2 squared is 4. That's still 24. But then -2 times 4 is going to give you -8. And then you still have a -5. So then this produces -13. And -13 subtracted from this gives you 11. All right. So you have an answer of 11. All right, so I did that one. Now the thing about this kind of question, and they did this on purpose to avoid you using the graphing calculator to do this, is that they gave you an equation that involved this x plus 1. What the heck does that mean? I mean, in respect to this. So this is why, again, I ask you to use these x's as replacement values. So what you do for this, okay, is you go ahead and take the parentheses and replace it with the x plus 1 squared, and then you have the x plus 1 for the x again, or what's multiplying against the 4, right? This is the replacement value that we're placing in this unique input of x plus 1. And then you have this. Now, this is a matter of FOILing, okay? So because it's FOIL, you have to go ahead and recall this formula, which I still have yet to really teach you. This is in this course, but you're going to get to know this right now, is that whenever you have a plus b, which is these two values, and it's being squared, the answer is a squared, and then it's plus 2ab, so you double the value of the a times the b, and then you go ahead and put plus b squared. So, looks like I need to be patient for a second. And we're back. Okay, now, right here, when we're doing this, okay, we're going to follow this to the T. So I'm going to take this is understood to be A, and this is understood to be B. All right, so I'm going to take A and square it, and I'm going to get x squared. I'm then going to take next 2 times A times B, which means 2 times x times 1, which is going to give me plus 2x. Because 2 times 1 is 2, 2 times x is x. And then I'm going to go ahead and get b squared, which is 1 squared, which is 1 times 1 is 1. So now I have that processed out. And then I'm going to go ahead and do the distributive property here. 4 times x is 4x. And then 4 times 1 is 4 minus 5. So I have now this. I'm going to do the distributive property, 6x squared. All right, so that's this. Now I'm going to do that. Plus 12x. And then 6. And now I have this so far. Are you hating me yet? I know. You're probably thinking, heck yeah. All right, it's not me. I'm just the messenger. All right, now I'm going to go ahead and bring these together because they have the same variable, x. So I have 6x squared, and then I have plus 16x is 4 plus 2 is 6. And then you have 10 because it's 12, whatever. And then you have 6 plus 4 is 10, minus 5 is 5. And now that is the answer we're looking for. We don't come up with a hard value like we did with these value systems. We're coming up with something completely unique in that we have that now. Okay? So a little different. All right? Now, when you put in a negative x, that's going to be a little easier. Putting a negative x is a lot easier. Because when we do that, all we're doing is putting in this is going to be negative x squared is still x squared. So it's going to be 6x squared because x times a negative is positive. And then when you put a negative x in here, it's going to switch that to negative 4x. And then you have the negative 5 and you're done. There's an answer for the last one here. That's a lot easier than what I just put your prove with this one. Okay? So I would understand if you're absolutely mad at me right now for this one, because this one is the hardest one. I tried to explain it in pieces, and the only way to best do this is by using this formula. You're going to appreciate this formula if you can get it memorized. I tell you that much. It's very helpful. All right, and they continue with this abuse on you, with this different types of situations. If you notice the second or the fourth one and the fifth one. Now with absolute value is the distance you are away from 0. So, and you can see that on the graphing calculator too. I kind of love using the graphing calculator. I had it up there before I cleared it, but if we go ahead and hit math, and then you go to num, AES is absolute value. That's going to be where you have the, if I do x minus 3, oops, that's not x. X is it. X minus 3. And then I have an 8 multiplying it. So I'm going to say second insert 8. I have now the equation. I can go ahead and hit graph. You can get a graph of that. Seen if I go ahead and do zoom 6, which is zoom standard. And there is our equation of our graph. Now, if I want to look at table values, second graph, there's our table values of input. So we can go ahead and do 0. 0 is 24. All right, there it is, 0, 24. So there's our answer for that one. All right, and then we have 2. 2 is right here, and that's the value of 8. And then negative 2 is right up in the top, and that is 40. So I kind of cheated a little bit by using the graphing calculator, like you guys said, takes all the fun out of it. All right, but now we have some more fun with putting in the last 2. So that's the 2 I'm concentrating on, isn't it? I know that's not possible to use a graph calculator. So we're going to go ahead and do x, and then x plus 1 for the value of input of the x. So that's what we get when we replace the value of x. So now at 1 minus 3 is going to be negative 2. And that's all I have for that. That's all I can do for that. There's nothing much I can do with that. So we're left with that. There's our answer. Okay. Now you'll notice how they put the answer like that. What did they do? They distributed the 8 to both things. Now I did not agree with doing that. Not necessary. If you put this answer as this, it would also accept it. So I challenge you to try in both ways, or if you feel like you want to go ahead and distribute it, go ahead and do it. You're more than welcome. All right, you can see that they accept that answer. I don't like doing that, but anyway, this is absolute value stuff. All right, now when we have this, we're going to go ahead and replace the x with x squared plus 2, and then minus 3. And then so all it is clean this up. And then we're going to go ahead and get negative 1. And then we're going to go ahead, if you want to, you can distribute it. I would leave it like this myself. But distributing it, it's just 8x squared minus 8. Heck of a lot easier than the question I did for you for this one. Okay. Now, when it's asking us for this question, it says below is a graph of this estimated close as possible to the value of H1, meaning what is the output value when 1 is the input value. So when 1 is the input value, the output value would be 3. So you just go to the input value of 1, that's on X, go to the output value of what Y is, and that is 3. And that's the answer. That seems very trivial to the problem we just did moments ago. Now, right here, it says evaluate 4 as the input. 4 is the input, is right here. That's going to be 3 as the output. All you got to do is look for where you're at 4. Your graph is right there. You can see that the output value is 3. What is the output, or what is the input value when you have the output value as 4? So look for where you have 4 for the output value and see that it's -2 for the input value. So -2 will produce the output value of 4, right? So that would be -2. A lot easier to explain these. All right. Now you have the town of Tola has a population of 20, and that's 1,000, and produces 7 tons of garbage each week. Express this information in terms of a function. So it says that the town population, that would be 20,000 people produce 7 tons of garbage. So it's the G is the garbage. So G output is that. It says and produces produced by a city of a population of P. So when we're looking at that, okay, we will go ahead and say that the output value of 20, wait a second, produces 7 times, so that would be 7 is the garbage, 7 times the garbage. So 7 equals, and then you have F of 20. So this is the equation that we're looking for producing that particular situation. Now, if you wrote it this way, the way I did it, that's okay. Better way of writing it is the F of 20 equals 7, but this is the same thing. So we're looking at just replacing the values of the F and the G, or not the F, but the P and the G, and that's given to us by the equation. Now, it says, suppose that you have a $240 gift card for gas. You spend on average $19 per week for gas. Write the function and model of the situation, where W is the number of weeks and G of W is the value of dollars remaining. So the W, or G of W, is equal to, that's what's remaining, is going to be $19 per week, and then you have $20 in the card. Well, wait a second, you're spending on average $19, right? So shouldn't that be negative? Because you're minusing it per week, $19 per week. So then you have to start 240, so our equation is this. And now once you have that, okay, I personally like it better this way because Y and X plus B. That's why I write it this way, by the way. I like NX plus B. All right, I don't like the way they wrote it, to be honest. Okay, so anyway, now it says evaluate when the input is G, so all you got to do is take your calculator and do 3 times -19 plus 240. Now, rather than being, I didn't prove that I can multiply, you can take your calculators and just simply take -19 times 3 plus 240. And you get 183, and that's our answer. All right? Don't have to be cute about it, just have to produce an answer. All right? Now, this is, again, a matter of a linear equation. You can do it by means of input and output, but this is pretty straightforward. -2 times -4 is positive 8, 8 plus 8 is 16. This is linear equation. So negative 1 times negative 4 is positive 4. 4 plus 8 is 12. 0 times 4 is 0. 0 plus 8 is 8. 1 times negative 4 is negative 4. Negative 4 plus 8 is 4. And then 2 times negative 4 is negative 8. Negative 8 plus 8 is 0. So that one's really moves fast. I've done all that mentally. Okay. So, but you may not be as quick as I am. And that's fine. I understand that. I mean, I'm a math guy, right? I've been doing this for a while. If you have the ability to use a calculator, but also by hand, as I've just indicated, and showing you on plenty of these questions. Now, using the graph, the function, domain, and range, domain is going to go from, wow, that's really small writing, but negative 9 to 6. All right, and then it's both open parentheses, and then it's from negative 7 to positive 8, both open parentheses. The x-intercept is at negative 1, is where you're crossing over the x-axis. The y-intercept is at negative 1 as well. That's where you're crossing over the y-axis. And the output value, or excuse me, input value of negative 5 would produce 6. I know it's really super small on your end. You can't barely read it. I can read it, but you can go ahead and zoom in if you want. But this is going to get in my way now, right? I can't answer the question. But input value of negative 5 produces the output value of 4. Or, yeah, output 4. So that's the answer for that one. And then I'm going to go ahead and say the input value of 5 produces the answer of negative 6. Is the relationship a function? Yes, it is. All right, and that is the last question that we have on this. Okay, so 32 questions. So we went over quite a few questions, and that is the conclusion of your homework 3 and 4 of Module 2.